All right, let's dive into a really critical but honestly often overlooked part of any tower system, the obstruction lighting cable.
So, you've done everything right. Your obstruction lighting system is totally up to spec, it passes all the FAA regulations, you've checked every single box. But here's the thing, there's a huge gap in those regulations. And that gap, it leaves the long-term reliability of your entire system resting squarely on your shoulders.
So here's the issue in a nutshell. The FAA advisory circular is incredibly specific about what the light itself has to do, right? Its intensity, its flash patterns, all of that. But it's almost completely silent on the actual lifeline that connects everything, the cable.
And that silence, well, that puts all the responsibility right on the design engineer. It's up to you to spec out a cable that can handle the full environmental, mechanical, and electrical load, not just for the first week, but for the next 20 years. And that, as you know, is where things can get really tricky.
So let's really look at what this cable is up against. I mean, what does it have to endure day in and day out for its entire service life? It's not exactly a friendly place to be. A tower-mounted cable is basically facing a constant 2-decade-long assault. We're talking unfiltered UV exposure, just baking the jacket material until it's brittle, extreme temperature swings from freezing nights to scorching afternoons. Then there's the constant threat of moisture getting in. And hey, if you're on a broadcast tower, you've got a ton of electromagnetic interference to deal with. Your standard off-the-shelf outdoor cable, it just wasn't built for this specific brutal combination of stressors.
You know, the real problem with using a standard cable is that the failure isn't immediate. It passes the initial inspection, it works just fine for a few years. It's basically a latent defect, a ticking clock hidden right inside the jacket. This timeline really shows you the hidden cost. For the first few years, a standard cable seems perfect, but somewhere around year 7, that constant environmental beating takes its toll. The jacket cracks, moisture seeps in, the system fails. And the really critical thing here is the timing. This failure happens long after the initial sign-off, when getting back up that tower for a full cable replacement is incredibly disruptive and expensive.
And let's be clear, the financial risk here isn't the few $100 you might save on the cable up front. The real risk is the tens of thousands of dollars it's going to cost for that unscheduled tower climb to replace the whole thing mid-life. That's the real cost of underspecification.
So to avoid that nightmare scenario, you need a totally different way of thinking. You can't start by flipping through a product catalog. You absolutely have to start with the application environment itself.
This really illustrates that fundamental shift in thinking. The standard way forces you to kind of jury-rig your system to fit whatever off-the-shelf cable you can find. The engineered approach, though, does the exact opposite. It builds the cable specifically for the environment it's going to live in for the next 20 years.
And here's what that actually looks like. Instead of some generic PVC jacket, you're specifying a UV-stabilized polyurethane or TPE that's engineered for that site-specific climate. Instead of a generic foil shield, you're using a foil, a braid, or a combination shield that's matched to the actual RF environment of the tower. And you're not just crossing your fingers hoping the jacket keeps water out, you're building in water-blocking tapes or gels to stop moisture before it can ever get started.
Now, this engineering-first approach isn't just about the materials, it's really about the process. To build a cable for a very specific environment, you need a different kind of collaboration altogether. This model demands direct communication. It basically collapses the whole supply chain so that your design engineers are talking directly to our manufacturing engineers. This way, you build the spec together, making sure every single environmental and electrical requirement is met and nothing gets lost in translation. This means no distributors. You're not trying to solve a complex engineering problem by talking to a salesperson who's just reading from a catalog.
And no middlemen, period. Your technical questions get answered right away by the very people who are designing and building your cable.
What this creates is a single point of responsibility. The same engineering team handles the spec, the cable, and the assembly. One team owns the entire outcome, from that first prototype all the way to long-term repeatable supply. So, the crucial point to take away from all this is really just a simple question you should ask yourself the next time you're writing a cable spec. Are you designing for year 1 or are you designing for year 20? Because the survival of your system absolutely depends on that answer.